Okay, we are recording, y'all. So what I'm covering today is 6.3, multiplication with division, sorry, multiplication and division and estimation with rational numbers. Okay, so the idea, again, what does multiplying mean, y'all? I'm just moving my mic here. What does multiplying mean? Multiplying means that we are adding repeatedly, okay? So if you notice right here, it says multiplication as a repeated addition. So what does 3 times 3/4 means? It means we have 3/4 plus 3/4 plus 3/4, which is the same thing as 9/4 or 2 1/4. So if you notice here, 3 times 3/4, we're taking the fraction 3/4. So again, here's the picture of it, right? So each one of those circles is cut up into 4 pieces. 3 of them are shaded. We're adding them up 3 times, right? And all they're kind of doing is you're saying, look, let's take this piece here and let's fill that one in. And then let's take these 2 pieces and put them over there. So we're going to have 2 complete circles and a fourth of the other one. Or they might say, as an improper fraction, we have 9/4. As an improper fraction, y'all, what I want you to notice is that each of those circles are cut up into 4 pieces. The reason why it's 9/4, 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are shaded, okay? And that's kind of the idea, right? That's what multiplication means. It just means I'm adding the same number multiple times, okay? Okay, so what we're going to do here, y'all, for these first couple of problems, they give me a picture and it says, in the following figures, a unit rectangle is used to illustrate the product of 2 fractions. Name the fractions and their products. Okay, so y'all, if I'm looking at this picture here, okay, and I say, look, this, we have a rectangle that's cut up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I got a rectangle that's cut up into 15 pieces, okay? So how many yellow pieces do we have? I have 1, 2, 3, 4, 5. So 5 yellow pieces. Okay, y'all, I can reduce this fraction. Okay, if I reduce that fraction, we can divide them both by 5. And that's going to give me a 1/3. Okay, and then we have another fraction. We have 1, 2, 3. So we have 3 out of the 15. I can reduce that fraction by dividing them both by 3. And that gives me 1/5. Okay. So what are my 2 individual fractions? My 2 individual fractions, y'all, are 1/3 and 1/5. Okay. So I want you to notice what the directions here say. It says the individual fractions are, it says type the integers or simplified fractions. Obviously, we're using simplified fractions. And it says use a comma to separate my answers. So I put 1/3, comma, 1/5. Okay. Now, what is the product of those 2 fractions? The product, y'all, means we're going to multiply them. So when we multiply fractions, the way we multiply fractions, y'all, is we just go straight across. So 1 times 1 gives me 1, 3 times 5 gives me 15. Now, I want you to look at the picture model that they gave us. I think it's a great picture model as long as you don't have color blind issues. But if I look at the picture model, right, when we did the first one, which was the little yellow squares, right? When I was looking at the little yellow squares, I said, look, we got 1, 2, 3, 4, 5, right? 5 out of the 15, right? With the blue ones, we said, look, we have 1, 2, 3, 3 out of the 15. Now, yellow and blue, y'all, don't yellow and blue make green? How many green squares do we have? We have 1 green out of 15, right? So again, visually, again, as long as you don't have color blind issues, I think it's a great way to kind of illustrate the problem. Obviously, if you do have color blind issues, I mean, it's not going to be as great, but hopefully, more of you don't have as many of those students, and then we can figure out something to do with them. But I think this would apply, kind of to the mass of your class, right? So look, I'm going to do the same thing for the second problem, right? I'm going to do the idea of yellow and blue make green, okay? So let's count our little yellow squares. Well, let's figure out how many squares we have total. So I got 1, 2, 3, 4, 5, 6. and 1, 2, 3, 4. So there's a total of 24 little squares, okay? So out of the 24, if I want to know how many of them are yellow, these would be the yellow ones, right? Because I know yellow and blue make green, so those are still going to be like yellow in there before, right? So how many do I have that are yellow? 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 and 5 gives me 20, right? These are my yellow ones, right? So let me go like this. Okay, I'm going to reduce this fraction, y'all. I'm going to divide them both by 4, okay? So 4 goes into 20 5 times, and 4 goes into 24 6 times. So my first fraction is a 5 over 6, okay? Now, let's do the blue ones, okay? So I'm going to think about my blue circles. All right, let me clean some of this mess up here. Okay, if I'm thinking about my blue circles, or my blue squares, I'm sorry, I keep saying circles. These are going to be my blue squares, right? So how many do I have? 1, 2, 3. 1, 2, 3, 4, 5, 6. So 6 times 3 is 18. 18 also out of 24, right? Again, I can reduce this fraction, y'all, by dividing them both by 6, right? So 6 goes into 18 3 times, and 6 goes into 24 4 times, okay? And now I'm going to go ahead and multiply. So when I multiply straight across, right, 5 over 6 times 3 over 4, and I go straight across. 5 times 3 is 15. 6 times 4 is 24. Okay. Again, y'all, I want you to think about my picture, right? Remember, yellow and blue make green, right? So how many green squares, or yeah, little squares do I have? 1, 2, 3. 1, 2, 3, 4, 5. So we have a total of 15 out of those 24, right? And again, the color thing, I think, hopefully makes a whole lot of sense, right? And it's visual. I can see what's happening. And again, y'all, I think I mentioned this before, but a lot of times we are visual learners. So when we see something, it's easier to understand it, right? And it's sort of like, I want you to kind of think about, like, if you've ever been to San Antonio, and when you're coming into San Antonio, there is this real big tower, and it's called the Tower. I know this is not a very pretty picture, but it's called the Tower of Americas, right? And there's a restaurant out there, and you got to take this elevator. And whether you've been inside the restaurant or not, if you've been to San Antonio, you've seen this tower, especially as you're driving in, right? And so if I were to describe this tower to you, and you've never been to San Antonio, it's kind of hard to understand. But if you've been to San Antonio and you've seen that tower, and you're coming into the San Antonio city limits, and you can see it in the, off in the distance, you know what that picture looks like, and that picture is in your mind. And so that's why I think a lot of times we're visual learners. If I were just to describe what the tower looks like to you, and again, I know that's a pretty ugly picture, but I were just to describe and you'd never seen it, it would be hard to understand. But once you've seen it, that memory keeps coming back, okay? Okay, excuse me. It says, find each of the following products, write the answers in simplest form. Okay, so y'all, what we're trying to do here, we're going to multiply. Now, again, this is something you would probably be doing with more of a 5th grade or 6th grade class, because our fractions are bigger here. But what I'm going to do for part A, 35 over 77 times 55 over, say, 140. What we're going to do is we don't want to just multiply straight across. We want to try to reduce our fractions. We want to try to make our fractions smaller. Okay, now, y'all, the way we make our fractions smaller is we reduce numbers on the top with numbers on the bottom, okay? So what I mean by that, this 35, I'm going to try to reduce it either with my 77 or with the number 140. I can reduce it with both of them if I can, because the 35 is on the top and both the 77 and the 140 are on the bottom. Okay, the same thing with the 55. I would reduce the 55 either with the 77 or with the 140 or with both of them. Okay, so when I think of 35, y'all, I think of, say, 5 times 7. And when I think of 77, I think of 7 times an 11. So this 7 here, again, I'm trying to show you how I would approach this with, say, 4th graders or 5th graders. I know that you all know how to reduce fractions, or you've seen it before, but this would be the process and how I would show somebody who's, say, in 5th grade or 6th grade. And I would say, look, I see the 7 here and I see the 7 here, so I can get rid of those 7s, okay? And then I would do the same kind of thing here, y'all. I would say, look, when I think of 55, I think of 5 times an 11. And I might say, look, I have an 11 on the top and I still have an 11 on the bottom. So I'm going to get rid of that 11 and that 11, okay? Now, I would look at the number 140. So you might say, okay, well, I think of 14 times 10. Okay, so let's go 14 times 10. But when I think of 10, I think of 2 times 5. So guys, I'm not thinking of my 10 anymore. I'm thinking of 14 and 2 and 5 to give me that 140. Now, if you notice over here, we don't have anything on the bottom over here because we canceled out both the 7s, the 7 here with that 7 there, and we canceled this 11 with that 11 over there. So now I still have a 5 right here, and I can cancel it with either one of these two. It doesn't matter which one I cancel it with, okay? So I might say, look, why don't I cancel it with this one, just because I want to show the idea that they don't have to be diagonal. They can be, one's, as long as one's on the top and one's in the bottom. So then I might say, okay, well, what do I still have on the top? Look, I never did anything with that 5, so let's leave that 5 alone. What do I still have on the bottom? A 14 times 2, which is a 28, right? Again, it's not so much do you know how to reduce fractions? I know y'all know how to reduce fractions. But again, this would be the approach on how I would show somebody who's in 6th grade or 7th grade or something like that, okay? Okay, look, let's do part B. So part B says, look, we have a D and a W, okay? Remember, y'all, W squared really means that there are 2 of them, okay? And the same thing with this D squared right here. It really means that there are 2 of those. Oops. Okay, so I'm going to do the same kind of thing here. I'm going to say, look, is there anything on the top that will cancel with the bottom? Look, we can get rid of this D with one of these. So let's go ahead and do that. And we can get rid of this W with one of these, okay? Doesn't matter which one, so let's get rid of that. So then what's the only thing I'm still left with on the top? I still have one W and I still have one D, okay? All right, and there is a part C, so let me do part C again. I'm gonna go the same approach, y'all. Again, what I'm trying to show you here, y'all, is how I would explain this to somebody who's, somebody who's in 5th grade or 6th grade or something like that, okay? So look, excuse me, I have an N and a B on the top. I have an A on the bottom, okay? And then over here, I have an A squared. Remember, an A squared just means I'm gonna write out the letter A twice. And I have the letter Q, okay? And an N to the third and a B squared. So N to the third means there's 1, 2, 3 of them, and a B squared means that there's 2 of them, okay? Okay, and now all I'm gonna do is I'm gonna start figuring out what I can cancel. So look, this N on the top will cancel with one of those. This A in the bottom will cancel with one of these over here on the top, okay? And then this B on the top will cancel with one of those B's, okay? So what are we still left with upstairs? We still have an A, and we still have a Q. On the bottom, if we have 2 N's, hey, that's really the same thing as N squared, and we're still left with the letter B, right? So again, I think a big part of, depending on what grade level you get, right? So, I mean, 5th graders might be even doing this too, probably more like in 6th grade. I think that's when they kind of start doing a little bit of the pre-algebra, so maybe 6th grade. And again, y'all, if you end up with a 6th grade class at some point, it's not so much can you do the problems, it's how would you show the students, right? And so I think really breaking the stuff down, and y'all, this is a really important part, is being able to break it down. I don't think I've told you guys yet. I'm going to tell you this right now. But when I was in school, I failed math in 7th, 8th, 9th, and 10th grade. Now, I was able to pass the year, but I would fail like a 6 weeks, or I failed a couple of 6 weeks. I know in ninth grade, I failed the second half of Algebra 1, but I had done well enough the first half of Algebra 1 that my overall grade still ended up passing, so I didn't have to go to summer school. I did fail geometry as a 10th grader, so I had to retake it as a senior. But I think a big part of it was, I don't know, 7th, 8th grade are definitely hard years. I don't know how you guys feel, but I think junior high is always kind of a hard time. But, so maybe, was I always paying attention? Probably not, right? I mean, when you're 13, you know everything, right? But I think being able to explain things and break stuff down is really, really important. Okay, so, we have a couple of properties here. The first one is called the identity property. The identity property just says, what happens when you multiply a number by 1? Well, you get the same number, right? 1 times some fraction a over b is still going to be a over b. And whether you multiply by 1 on the left side or 1 on the right side, it really doesn't matter, okay? And then we have something called the multiplicative inverse property of rational numbers. It just says that for any non-zero rational number, so the number is not 0, we have a fraction. The multiplicative inverse is what we call the reciprocal. The reciprocal just means flip the fraction, okay? So what we're going to do here for each of these problems, we're just going to flip the fraction, okay? When it says find the multiplicative inverse, it just means we are looking for the reciprocal, okay? So for part A, the reciprocal of a negative 1 over 2 would be a negative 2 over 1. Now, I'm not certain how MyLab is going to ask you to do it, but I know that when I take a number and I divide it by 1, it's really just whatever I have on top, okay? Now, y'all, for part B, the way I would find the multiplicative inverse is I would first say, let me change this to an improper fraction. So we talked about this last week. Remember how it changes to an improper fraction? I would say, look, we're going to take 2 times 1 is 2. We're going to add 1 more to that. So that's 3 over 2. So now if I just flip it, the reciprocal will be 2/3, okay? And then part C, z over y, if I just flip it, it's y over z, right? Now, if I look at D, y'all, I want to think of this as a fraction. Remember, I can think of this as a fraction by writing it over 1, right? So if I'm going to take the reciprocal of that, that's just going to be 1 over a negative 7, right? And we found the multiplicative inverse of each of those fractions. All we did was flip them. So again, y'all, one thing I really want to emphasize here is that if I have a mixed number, write it as an improper fraction, because now we can flip the top and the bottom, okay? Okay, so the next part says, show that the following properties do not hold for division of real numbers. Okay, commutative. So guys, just to, again, it's been a little while since we talked about the commutative property, but I just want to kind of show you what the commutative property says. Excuse me. For addition, the commutative property just says 3 plus 2 is the same thing as 2 plus 3, okay? So what did I really do here? All I did is switch the order, right? I know if I have 3 plus 2, that's really the same thing as 2 plus 3. Now, it also works when we multiply. 3 times 2 is the same thing as 2 times 3. So the commutative property, y'all, works for adding, and it works for multiplying, okay? So they're telling me, show that it does not hold for the division of rational numbers, okay? So it says the commutative property for an operation says which of the following? It says that the order of the numbers does not matter, right? Because whether I add the 3 and then the 2, or the 2 and then the 3, or whether I multiply them, it's not going to make any difference. But that's what the commutative property says, okay? Now, there is a part B to this problem, y'all, okay? And part B says, if the commutative property did hold, which would the following be true? Remember, look how I'm doing these problems. All I'm doing is I'm just switching the order of the numbers, right? So when I do this part here, if it did hold true, what I would say is, look at A. All we're doing is switching the numbers for the orders, right? The order of the numbers, I'm sorry. So if it was true, that's what I would do, okay? Now, there's like a third part to the question. It says, give an example that the commutative property is not true for division. So again, which one here switches the order of the two numbers? Y'all, D switches the order, okay? And look what it's saying. 12 divided by 3 is not the same thing as 3 divided by 12. Okay, just to give you an example, y'all, because today is Halloween, okay? So I'm going to show you why it does not hold true. Okay, 12 divided by 3. Suppose this means, because again, today is Halloween, right? And if I teach this class again, y'all, it may not be Halloween, but you'll get the idea. Okay, suppose we have 12 candies and there's 3 of us. If there was 12 candies and we had to share those candies equally, each person would get 4 candies, right, for one person here. Now, I'm going to do the same thing over here, y'all. The number on the top represents the number of candies. The number on the bottom represents the number of people. If there was 3 candies, but there was 12 of us, that would be a very different scenario. That would mean that there would be 1 candy for 4 people. And that's a much different scenario, right? If there was 12 candies and there was 3 of us, we each going to get 4 candy bars, right? But if there's only 3 candy bars and there's 12 of us, that means among 4 of us, we got to share 1 candy bar. Hey, that's a really different scenario, right? So that's why we say the commutative property does not hold, okay? All right, let's take a look at the next one, the associative property. Okay, so the associative property, y'all, the associative property, again, it's been a little while since we've talked about this, so that's why I want to show you what the associative property does. If I'm adding, and when I'm adding more than 2 numbers, like 3 numbers, the associative property says, which ones do I add first and which ones do I add second doesn't really matter, okay? So again, if you notice, y'all, if I were to do what's in parentheses first, 3 plus 1, that would give me 4. And if I said 2 plus 4, that's going to give me 6, right? Now, again, if I'm adding, I would do what's in parentheses first. 2 plus 3, hey, that would give me 5. 5 plus 1, that would still give me 6. The commutative property just refers to which numbers am I grouping together, right? So look at part B. It says the associative property for an operation says which of the following. It says the operation can be applied regardless of how the numbers are grouped. Because when we group them differently, when it comes, say, to adding, guys, it also works for multiplying. The associative property works, okay? I can group either the first 2 and then do the last one, or do the last 2 and then do the first one, okay? So now it says, look, if the associative property did hold for division, which one would be true? So again, I'm looking at dividing. So the only operation I want to see here, y'all, is dividing, and the grouping would not matter. And that would be choice D, because look at the grouping is different, right? But everything is dividing here. The reason why I would not look at this one is because the operation between those two, y'all, is multiplying. And all we're doing is looking at division here, okay? So that's why I know that these are not the ones that I want to do, okay? Now, again, there's going to be an example. It's going to say, look, show me which ones would be not the same, okay? So if I look at choice D again here, y'all, I could show that this is not going to be the same. Look, if we're going to do what's in parentheses first, 24 divided by 6 would be 4, and then 4 divided by 2 is 2, okay? If we're going to do these first, 6 divided by 2 is 3, and 24 divided by 3 is 8, and that's why those two things are not the same. So again, D would be my answer here. And again, I can't use the associative property for dividing. It doesn't work. So the associative property only works for adding and multiplying, okay? Doesn't work for dividing, and it doesn't work for subtracting either. Okay, so for the next couple of problems, y'all, it says use ranges to approximate the following computations. What I mean by using ranges, we're going to go with lower ranges versus upper ranges, okay? Y'all, when you're doing this problem here in my lab, it's going to be a multiple choice type problem, okay? So when I say by using ranges, let's see, 6 1/3. If I were to think of the number 6 1/3, if I was going to round that till the nearest whole number, okay, so I want you to think about a circle that's cut up into three pieces. 1/3 would look something like that. Okay, that's what 1/3 would look like. Now, have we shaded at least half that circle? No, right? So 6 1/3, y'all, I would really compare that more to the number six. That's the lower range of six, right? It's more of a lower estimate. Okay. Now, 2 7/8. I want you to think about what 7/8 looks like. 7/8 means take a circle, cut it up into 8 pieces, and we're going to shade 7 of them. Okay. We've shaded almost that complete circle. We didn't shade this piece right here, but we shaded most of that circle. So 2 7/8, I would probably round that up to something like 3. And if I were to multiply 6 times 3, that would give me 18. Okay. Okay, when I look at the next one, 5 and 6/11. Again, y'all, as long as my fraction is more than half, I'm going to go ahead and round it up. So if I wanted to know, is this more than half? An easy way you could do that is multiply this number here by 2. If it's bigger than or equal to this number, then you can go ahead and round up. So what do I mean by that? What's 6 times 2? That's 12. Okay, that's already more than that number. So let's go ahead and round up that 5 to a 6. Okay. 8 and 7/100. Look, y'all, if I were to multiply 7 times 2, that's 14. That is nowhere near half of 100. So I'm going to leave that 8 as an 8. So what's 6 times 8 going to give me? That's going to give me 48. Okay. Now, again, we haven't really talked about this part so much, so I'm going to go ahead and walk y'all through it. Y'all, if you remember, you might remember this from elementary school or junior high or whatever, but in case you don't, I'm going to show you. How do we divide fractions? The way we divide fractions, y'all, is we actually multiply by the reciprocal, okay? So I'm going to change that to 113/1. Now, again, y'all, if I think about this, this is 113/11 if I multiply straight across, right? Okay. Now, if I were to, again, I want to estimate this thing here, right? So if I'm going to estimate this something like this, y'all think about changing that to an to a mixed number, I'm sorry. That would mean we're going to take 111 and divide it into 113. How many times would it go in? Hey, it's only going to go in one time, right? And what's my remainder? My remainder is 2. So this number here, y'all, is really close to the number 1, right? Because it's 1 and 2 out of 111, right? The number really, as a mixed number, it's 1 and 2 out of 111, and that is nowhere near, right? If you were to multiply that 2 by 2, that's nowhere near 111, so I could just drop off that little piece, right? Okay, so again, y'all, just to point something out here, and I'm gonna do this real quick just to make sure everybody understands this. Let me come back to my lab. This is 6.3. I want to kind of just show you what I'm talking about here. Let me see if I can find the problem. Let's see. I think it is the one before this. Here we go. Okay, so look, I'm just going to do part A. And again, I'm just going to do a little copy and paste here because I want to show you how, again, it's giving me a multiple choice type idea here, okay? So look, let me just do part A, just to kind of show you. Oops, that's not what I wanted to do. Let's get rid of that. Let's do it over here. There we go. Okay, so it says, look, choose the best approximation for 5 1/5 and 3 4/5. Okay, so y'all, if I was going to do something like this, I would say, look, 5 1/5, that's really close to 5. Okay, 3 4/5, that's really close to 4. Okay, so what's 5 times 4 going to give me? That's going to give me 20, and that would be my approximation. I would probably go with 20. as my choice, right? And again, y'all, if I were to come back over here, I'm going to choose 20. Let's see. Let me see what it says. Are we good? Yeah, there we go, right? And again, that would be my approach on how I would do something like this, okay? But again, it's multiple choice, right? So I kind of just wanted to show you the idea and what I was doing there, okay? Okay, so the next part, y'all, it says of. What does of mean to do? Of means to multiply. Okay, so again, this is more, these next few problems, y'all, that we're going to do are more definitely in the junior high range. This is definitely more in the 6th to 8th grade level, right? So again, and I've said before, y'all, and I know most of y'all really are looking more for 1st grade, 2nd grade, kinder, 3rd grade, 4th grade, maybe 5th, but this class really does prep you for any of those levels, right? Anything between K and 8. So that's why we go through some of this stuff here. But let's take a look at the first problem here. It says 5, 6. So y'all, the first thing I'm going to do, I'm going to write out that fraction, 5, 6. 5, 6 just means 5 over 6. The next thing I know, I see the word of. And what does of mean to do? It means to multiply. Okay, it says 5/6 of the students at a nearby college live in dorms. If 6,000 students at the college live in dorms, how many students are there in the college? Okay, so look, 5/6 of the students at a nearby college. I have no idea how many students are in that college. I'm going to call that X. Okay, these are the number of people that live in dorms. But how many students live in dorms? Well, 6,000 of them do. Okay, again, y'all, this is more, I really want to emphasize this. This is really more in the 6th to 8th grade level. So if you're trying to show a student, how would you do this, right? So number one, you'd write out the problem, which we did. And you would say, okay, look, how do I get rid of the 5 over 6? By using that multiplicative inverse and multiplying everything by 6 over 5, okay? And this is how I would approach my problem. And remember, just like we said before, when there's a number on the top and the number on the bottom, they're going to cancel. So you would show your students, look, this 5 will cancel with that 5, and this 6 will cancel with that 6. And here's my X, right? And then you might say, look, do you think we can divide 6,000 by, say, 5? And you'd say, yeah, we can. Look, if I take 6,000 and I divide it by 5, I'm going to get 1,200. So this 5 here is going to go into 6,000 1,200 times. Okay. And now we're going to multiply straight across. 12 times 6, or 1,200 times 6, is going to give me a 7,200. And this is telling me the total number of students. Okay. So out of the 7,200 students that go to this college, 6,000 of them live in the dorms. Okay. But again, the approach is more like, how would you show this to a 6th grader, a 7th grader, or 8th grader? And again, this might be really more in the 7th or 8th grade, maybe even more in just the strictly 8th grade. Okay, but again, it's the approach and how you're showing them, right? Okay, so look, y'all, I'm going to do the same kind of idea here. It says Rob owns 3/5 of the stock in a local bread company. His sister owns half as much stock as Rob. What part of the stock is owned by neither Rob or Talia? Okay, so what I want to do here, y'all, let's figure out how much Rob owns. So we know Rob owns 3/5, right? His sister Talia owns half as much he does. So look, we're going to take half of 3/5. That's going to be 3/10, okay? So y'all, I'm going to show you all this visually because this problem here, I mean, you can probably even show this to like a 4th or 5th grader. So look, y'all, this is how I would kind of illustrate this problem. I'm going to cut this in half. 1, 2, 3, 4. Okay. And I'm going to kind of try to draw my lines as best as I can. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, I'm missing a piece. Which line did I not use? That one goes there. This one goes here. Maybe like that. Okay, so I'm trying to cut up into 5 equal pieces. I know my picture is a little messy. But look, here's 3/10, right? So look, 3/10 y'all would say, look, Talia owns 3 of those 10, right? If I wanted to look at Rob's though, Rob's is 3/5. Okay. So y'all, if I wanted to think about that with a denominator of 10, I could multiply this here by 2 and this here by 2. So that would give me 6 over 10. So look, I'm going to go like this. 1, 2, 3, 4, 5, 6. There we go. Okay. What part is owned by neither Rob or Talia? And I would say, look right here, that one piece. But that's one piece out of how many? How we cut up that circle into how many pieces? 10, didn't we? So how much is neither owned by Rob or Talia? 1/10, right? Whatever's left over, right? So Rob had 6 out of the 10 because 6 out of the 10 is the same thing as 3/5. Talia had 3 out of the 10. So one more out of the 10 would be whatever's left over. Okay. All right. Now, the next part says a dress is on sale for $168. Okay, what's the original price of the dress if the discount was 1/5 of the original price? Okay, so I want you to think about this, y'all. I'm going to take a circle here. Okay, I'm going to cut it up into 5 equal pieces, or try to cut it up into 5 equal pieces. So 1, 2, 3, 4, 5. There we go. Okay, so it says a dress was on sale for $168. What's the original price if the discount was 1/5 of the original price? So look, y'all, this is what they did. If we have a circle, this circle here, y'all, represents, say, the total cost, right? Okay, the reason why I cut it up into 5 equal pieces is because my denominator here was 5. So look what they did. They said they discounted 1/5. So what does that mean that they did? They took away one of those pieces, right? How many pieces do I still have left though? If we took away 1 out of the 5, how many do we still have left? We still got 4 of them, right? So 4/5 of the original price is what my sale price is, $168, right? I'm still left with 4/5. What I'm trying to do is I'm trying to find the total cost. Again, the way I would show this to a 7th grader or an 8th grader is I'd say, look, if I have 4 over 5, let me multiply by my reciprocal, 5 over 4, okay? So that I know that this 4 on the bottom will cancel with that 4 on the top, and that 5 on the top will cancel with that 5 on the bottom. And then, y'all, what I would do is I say, look, remember, when the number's on the bottom, that means that number is dividing. So I know that 4 does not go in nice and pretty into 5, but I want to know if it would go nice and pretty into 168, right? So I'd take my calculator, 168, I would divide it by 4, goes in nice and pretty, 42 times. So this is a 42. And then what am I going to do with those two numbers? I'm now going to multiply them. So I'm going to say, what's 42 times 5? And that's going to give me 210. And that was the original price of the dress. Okay. All right. So y'all, for this next problem, I had kind of these next two actually, I had debated putting them on here because they're definitely more of the challenging problems. But again, you know, if you end up with like, say, an 8th grade class and it's an 8th grade GT class, you know, hopefully they don't throw you into something as it advanced like in your first year, but you know, maybe this year, say it's your 5th year or whatever. Again, how would I approach is really the whole point of this class. How would I approach this with a student? Okay. And y'all, even when I was, you know, going through this myself, you know, and I've been teaching 25 years, I was really trying to understand the process, right? So it's not something, you know, guys, one thing I'll always tell you, whenever you're teaching, whenever you don't know, ask somebody else. It's okay to ask. It's better to ask and get that clarification than to kind of go in there thinking, well, I don't want to ask because I'm afraid they're going to think I'm dumb. Guys, when we're in the teaching field, the whole point is to help each other out, right? So guys, even myself, I've been teaching 25 years. Right before the pandemic hit, I taught statistics for the very first time. right? I taught it in 19. I've been teaching 22, 23 years, and I hadn't yet taught stats. The way I got ready for stats is a friend of mine who teaches in McAllen was teaching statistics that summer. I went to his class Monday through Friday at 7:30 in the morning, and I sat in his class so I could learn stats because it had been such a long time since I'd seen that material, right? And he's like, come on in. So every day, and I'm not a morning guy, y'all. So I was up at 6 o'clock every morning, right? Got my coffee going, showered, brushed my teeth, all that kind of fun stuff. And I went and I sat in on stats. But then what? After that, I started teaching. I got better at it, right? So the idea is we always try to help each other out. Okay, so let's take a look at this problem here. It says John took all of his money from his savings account. Okay, he spent $72 on a radio and 2/3 of what was left on presents for his friends. Of the money remaining, John put 5/12 into a checking account, and the last remaining 140 was left to charity. How much money did John originally have in his savings account? Okay, so this problem, y'all, is definitely a complex problem. And the one thing I always tell my students is when you're doing a word problem, you got to read it. Second thing you got to do is you got to read it again. Okay, John took all his money from his savings account. He spent $72 on a radio, and 2/3 of what was left was for presents for his friends. Of the money remaining, John put 5/12 into a checking account, and the last remaining 140 was left to charity. How much did John originally have in his savings account? I don't know, but this tells me what I'm trying to find. Okay, let's let X be the money in John's account. Okay, so look, y'all, I'm going to do this in like a little process. John has a certain amount of money. How much did he spend right away? He spent $72, right? Okay, so look, let's go like this. Let's take away 72. And then 2/3 of what was left went to presents for his friends. So this right here, y'all, this goes to presents. Okay. Now, right here, of the money remaining. Okay, look, y'all. Think about that circle 2/3. Think about a circle that looks like this, 2/3. Here's a circle. I'm going to shade 2/3. Okay. So that right here went to presents. How much is still left? 1 out of the 3. Okay. So of the money remaining, y'all, would be 1/3 of X minus 72. Okay. Of that amount, 5/12 went into a checking account. What was left over? $140. Okay, so I want you to think about 5/12. Okay, look, y'all, I'm going to draw a picture again. I'm going to try to cut this into 12 equal pieces. Okay, 1, 2, 3, 4, 5. I'm sorry? Okay, right here. Remember what we said? If I draw a circle, right, I'm going to cut it into 3 pieces. Why? Because it was 2/3, right? Look what it said. This amount here went to his friends, right? Went to presents for his friends. How much was left over? 1 out of the 3. That's why I have that 1 out of the 3 right there. Okay. Now I'm going to do the same thing here. Look, y'all, I'm going to draw a circle. I'm going to cut it into 12 pieces because of that 12's right there. So look, this is how I'm going to do it. 1, 2, 3, 4, 5. Okay, let me see if I can do this. 1, 2, 3, 4, 5. Okay, there's 12 pieces right there. Okay, look how much went into a checking account. 5/12 of that. So look, I'm going to go 1, 2, 3, 4, 5. Right? That's 5/12. How many 12s are left over? 1, 2, 3, 4, 5, 6, 7. So my next step is going to be 7/12 of this number is equal to the amount that was left to charity. And how much of it was left to charity? 140. So guys, like I said, this is really one of the more complex problems. What it does for me, y'all, is it helps me realize, excuse me, it helps me realize how much is left over. Now, I want to show you all something else. Before I go on, I want to show you guys something here. Remember when we had this fraction 2/3 and I said, look, here's the circle cut up into 3 pieces. If 2/3 goes, what's left over? 1/3. Think about it this way, y'all. What's 3 minus 2? 3 minus 2 is 1. That's the number that I have right here, okay? Look, here's my second circle, 12 equal pieces, 1, 2, 3, 4, 5. How many are left over? 7. Think about it this way, 12 minus 5 gives me that 7, okay? Now, y'all, I'm gonna go ahead and solve this part here. So I'm gonna do it in pieces. I'm gonna say, look, how would I get rid of the 12 over 7? We'd multiply by, by 7 over 12, I'd multiply by 12 over 7. So look, I'm gonna go 12 over 7 here. This 7 and that 7 will cancel. That 12 and that 12 will cancel. This is a 1/3 x minus 72 equals. Again, I'm going to go real slow here, y'all. 7 I know doesn't go into 12, but it should go into 140. So look, 140 divided by 7 is 20. So that number's at 20. So what's 20 times 12? Oops. 20 times 12 is 240. Okay. Now I have to get rid of the next fraction. It is a 1/3. How do I get rid of a 1/3? I multiply by 3 over 1. Okay. So that 3 and that 3 are going to cancel. I have an x minus 72. Look, y'all, 1 goes into 240, 240 times. Multiply that number by 3. That's a 720. Okay. Remember, I'm trying to get the x by itself. If I have a minus 72, what am I going to do? I'm going to do the opposite. I'm going to add 72 to both sides. So 720 plus 72 should give me something like 792. And that's how much money John had in his account. It's sort of a way of working backwards, y'all. But again, I think it's sort of the idea of if you gave away 2/3, how much did you still have left over? Well, if I gave away 2 out of the 3, I still had to have 1. And if I gave away 5 out of the 12, well, I still had to have 7 out of the 12 left over. Okay. So look, let's try the next one. It's going to be a similar type problem. Okay. And again, y'all, I know that these couple of problems here are a little challenging. So again, if you guys need help with anything, send me a picture. You know, I'm be happy to make you guys a video. Okay, it says Al saves pennies. He agreed to give 1/3 of his pennies to Bev if she would give 1/3 of what she got from Al to Carl, and Carl would give 1/3 of what he got from Bev to Danny. Bev, Carl, and Danny agreed, and Danny received 9 pennies. How many pennies did Al have initially? I don't know. Okay, so look, y'all, this is what we're going to do. X is going to be Al's pennies, okay? Now, how many is Bev going to get? She's going to get 1/3. Okay, she's going to get 1/3 of whatever Al has, right? Okay, who's the next person we have? We have Carl. How much is Carl going to get? Carl's going to get 1/3 of whatever Bev got, okay? And then how much is Danny going to get? Danny's going to get 1/3 of whatever Carl got. So 1/3 of 1/3 of 1/3 X, and that's going to be equal to Danny's pennies. Okay. Now, how many pennies did Danny get? Danny only got 9 pennies. Okay. So look, y'all, I'm going to write 1/3. Oops. I'm going to write 1/3 of 1/3 of 1/3 X is equal to 9. Okay. And again, I'm going to kind of walk you through the process. There's a couple of ways you can go about doing this. But one way you can do this is you can say, look, how would I get rid of this 3 here? Well, let's multiply by 3 over 1. Okay, so this 3 and that 3 cancel. So I'm still going to be left with a 1/3 and a 1/3 X equals 9 times 3 is 27. Okay, And then you might say, well, look, how am I going to get rid of this 1/3? Well, let's multiply by 3 over 1 again. Okay, so this 3 and that 3 cancel. So I still have that 1/3 x. 27 times 3, 81. Okay, and then you might say, well, how am I going to get rid of this 1/3? Well, look, I'm going to have to do that a third time so that those 3's cancel. And that's how many pennies Al had. Al had 243 pennies, right? But again, it's sort of a process. You're kind of going through the process of showing, say, an 8th grader how you would approach this, right? And you say, well, look, how do I get rid of that first 1/3? Multiply by 3, right? And it's sort of repetitive, but hopefully they would see kind of the idea. Okay. All right. So, y'all, for these next couple of problems, I'll tell you what, I'm gonna remove this problem from your homework, y'all. I really don't think that this is something you're gonna see in the 6th, 7th, or 8th grade level. I mean, this is definitely more of a 9th grade kind of thing. So I'm gonna hold off on this problem. I'll remove it from your homework so that you won't have to do it. But I am gonna look at, let's see. I'm gonna just do the same thing with this one too here, y'all guys. I'm gonna pull that problem and I'm gonna double check in the homework to make sure, and make sure in the quiz that you don't have that problem, okay? I am going to show you these next two though, because I think these next two are something that you could see in a 6th grade class or a 7th grade class, okay? So it says, solve for the integer n in each of the following. And guys, I'll make sure that if those problems show up on the review, I'll make sure that I pull those problems too. I don't think I'll put them on the review, but I'll double check, okay? Okay, so it says solve for the integer in each of the following problems. Okay, 2n equals 64. So y'all, again, if I was sitting where you're sitting, what I would do here, y'all, 2n equals 64. What I'm going to do is I'm going to break down the number 64. Okay, so 64, when I think of 64, y'all, I think of 8 and 8. Okay, when I think of 8, I think of 2 and 4. Okay. Now, I can't break down the 2's, so I'm going to leave those alone. But when I think of 4, I think of 2 and 2. Okay. So what I'm doing here, y'all, is I'm looking at all the numbers that I have at the bottom. Okay. What I mean by that means I'm not looking at the 64 anymore. I'm not looking at the 8's, and I'm not looking at the 4's. I'm just looking at these numbers here. So I would say 2n equals 1, 2, 3, 4, 5, 6. There's 6 2's. Okay. So if 2 to the n, y'all, is equal to 2 to the 6, we do a little stare and compare. If we say this whole number is equal to that whole number, and these are both 2's, then n has to be the same thing as the power right there. Okay. Okay, when I think of n squared, remember what n squared means? A number times itself. Do you know what number times itself would give you 25? What, besides 25 and 1, what else multiplies to 25? Anybody know? Wouldn't it be 5 and 5? Okay, so for part B, y'all, I would say, look, n is 5, but could we also do this? Isn't a -5 times another -5 still a positive 25? Yeah, it is. So we actually have two answers here, y'all. One of them is going to be 5, and one of them is going to be 25. Okay. All right. Y'all, for the next one here, when I'm looking at part C, what I want to do here, when we're multiplying two numbers with the same base, when they're both 2's, what we can do, y'all, is we can write it as 1, 2 with those powers being added to each other. Okay. Just like we did in the first problem, y'all, when the whole number here and that whole number are the same, and this piece right here and this piece are the same, then we can say this piece, n plus 9, has to be equal to 6. So if I was going to solve for n, what would I do? I'd have to subtract 9. And if I have $6, but I owe you 9, I'm going to owe you 3. That's why it's a -3. Okay. Okay. Because it's a 6 right here. Yeah. Good question. So look, y'all, let's take a look at part D. Look, I'm going to do the same thing. When these two numbers are being multiplied and they're both twos, we can write 1, 2 with the powers being added. Okay. So look, 2 raised to the power n plus 9 is equal to 8. Now, what I really want to do here, y'all, I want to break up my number 8. So I know 8 is 2 times 4. Now, I can't break up 2, but I can break up 4 into 2 and 2. So look, y'all, I'm going to say 2 to the power n plus 9. Instead of me writing 8, I can say 8 is really the same thing as 2 to the third because there's 3 2's there. And just like we did in the previous problem, y'all, when this number here is the same and they're both 2's, and by the way, y'all, they don't have to be 2's, they can be 5's. The idea is they have to be the same. Okay, for this problem, the ones that I got was 2's. But if you had 5's, you would do the same thing. You're going to say that this piece here is equal to that. So n plus 9 is equal to 3. So look, y'all, if I were to subtract 9 on both sides, I would get a minus 6. Okay. Okay, so we got one last problem to do here, y'all. So let's go ahead and do it to it. Okay. Look what it says. It says, if 3 out of 31 of all rabbits in a country are in one state, and 1/6 of the rabbits are in a different state, what total fractional part of the rabbit population is in those two states? Okay, so look, y'all, we're going to take 3 out of 31, right? Those are the fraction of rabbits that are in one state. And 1/6 of the rabbits are in another state. It says, what total fractional? The total, y'all, just means all we're going to do is add those two fractions together. Now, y'all, when we were talking about adding fractions together, one thing we always said is, you know what we need to get? We need to get a common denominator, okay? And one of the things that we did a lot, y'all, and I'm just going to kind of come back to my Blackboard page. Let me come back this way. Let me get rid of that. And one thing I would do a lot, y'all, is I would get my multiplication table, right? And so, y'all, I'm just going to kind of make up an example here. Look, so I have 3 over 31 and 1/6, okay? So, y'all, suppose I was going to add two fractions together, and I'm going to make this up. Suppose the denominators, I know that in my case I have different numbers, but suppose my denominators were like, say, 4 and 5. I would say, look, let's look at the 4's. Let's look at the 5's. The first number we have in common is 20. That'd be the way we would do it. In our case, we have a 31 and a 6. So y'all, if I look, I do have a 6, but I definitely don't have a 31, right? So the way I would approach this, y'all, would be one way that we can find a common denominator, and it may or may not be the smallest, but it's okay as long as it's a common denominator, is we could say, look, let's take 31 and 6, and let's multiply those two numbers together. So 6 times 1 is 6, 6 times 3 is 18. We can write both of those denominators with 186, okay? And then we're going to just play the same game. We're going to say, look, what did we multiply 31 by to get 186? Hey, we did that by 6. So we got to do the top by 6. That's an 18, okay? And what did we multiply 6 by to get 100? Oh, we multiplied that by 31. So we got to do this by 31. So that's a 31 right there, okay? And then all I would do now, y'all, is I would add those two fractions together. Remember, my denominator stays the same. And 18 and 31, if I were to add those together, would give me a 49. And there would be my answer, 49 out of 186, right? And again, just because my denominators aren't as pretty as like the ones we did before, doesn't mean we can't do it. It just means that we got to do it a little bit of a different method, okay? So, y'all, that should be the end of 6.3 because I believe, yeah, 6.4 starts over here. So let me go ahead and stop recording.